This is the application we're going to use. It's a Python application developed with Dash, which is a library that allows you to have things like this. And it's a very simple display of the relevant information we need to use and retrieve. And the looks might change over time, but the essence of what you will see it's exactly the same. So this is the first version I've developed. So as I keep improving the interface, probably you might be looking at something different from the screen I'm showing right now. But anyways, what you have is information regarding the tasks, which is the durations from 3 to 3 for the 12 tasks you have. This is what you had in the tables I showed before. And you have another table, a matrix, for representing the precedences. So when you have an X or any character you put in, means that you have a precedence. So that means that task 3 precedes tasks 6 and 7, or task 10 precedes task 12. Okay, and this is the input information along with the number of positions you have per station. One thing I haven't explained before is that if you have, instead of one station, you have two stations or two positions in one station, that means that you can do the operations for that station in two different stations, into different positions. So that means that the time you need to employ is actually divided by 2. So you go twice as fast. So increasing the number of positions you have in a station means reducing the time devoted to the operations in that station by 2. Okay, that requires an investment, but in exchange you have increased your capacity. The extreme situation, of course, is you duplicate all stations, and in that case it's like having 2 lines, and you would be reducing the cycle time by 2. Okay, you will be having a cycle with the cycle time which is half the cycle time you had. Okay, and for you to explore a solution, you will have to change durations, precedences, and the number of positions per station. And as an output, what you will get is where you have model.solves, you will have here the cycle time. You will have the table we are trying to find, which is for each task, which is the station where you should perform it. Okay, you can scroll down to see the whole list. And finally, you have some output information, which is the sum of all the times of the tasks that are performed in every station, as the calculation I did manually in a previous step. So we have a set of buttons here. We can solve the model, which is, okay, tell me what the solution is, minimize the cycle time. You can reset anytime you click reset. What you do is you get back to the original values. So you play around with the tool and you get lost at some time, you just can press reset and you'll be back at point 0. You can add or remove stations and add and remove tasks. Okay, let's solve the model as is. And what we get is that our cycle time is 20. That means we're producing 3 amplifiers per hour. And you can see here what is the assignment. Task 1 has to be in station 1, the same for station 2, 3, and 5. You'll do task C in station 2, task 8, okay, and then you have tasks 4, okay, 7 and 9, station 3, and finally the rest, which are only tasks 10, 11, and 12, will be done in station 4. If you sum the times of the tasks you're doing in station 1, you have a time of 20. If you do the same for station 2, you have 19, 17, and 20. So the lowest are both station 1 and 4. So that's why you're producing at 3 amplifiers per hour, because you're producing at the lowest pace, which is 20 minutes every 2 amplifiers. Okay, so if we used those 4 stations as they are right now, this is the maximum production we could get. So we can have an idea of how much would our production be and how much money we can make, and we have an estimate of the maximum income we can have. But we can, for example, add another station. We can do this. Okay, this is one of the tasks you have to do, and we can solve the model. And what we get is that since we have one more station to assign tasks, we have lower times for our stations. So now the slowest goes at a pace of 16 minutes in between two amplifiers. So we've reduced the cycle time from 22 to 16. The point is this investment worth doing? So reducing my cycle time from 20 to 16 pays off in the investment, because I have to spend some money because I need a whole new station. So is that something that has a good return in terms of investment? Okay, and I can remove the station, okay, and go back to where I was, or I can add more stations. Okay, notice that I'm going to add a lot of stations. Okay, and I solve, and what I get is that the cycle time is 13, and I cannot go further than that. Okay, because the longest task takes 30 minutes, so there's no way I can divide that task into two. I could change the capacity of the stations, and that would have an impact. Okay, you'll see that when you experiment. So let's back to our original situation, and imagine we are at a new task 12, which has a duration of, I don't know, let's say 1, but you have your own data to explore. And I can tell the model that, okay, I'll use a different value. Let's use 5. Okay, and I'm going to say that this is a task that I can do at any time. There's no precedence regarding this task. I can solve the model, and I have a cycle time of 21. But what if I had to perform 12 before to a task 13? I can just type an X here. Okay, it's not case sensitive. You can just have any value here, and you can solve it. Okay, still we have the same value. Let's add some precedences. Okay, let's see. Let's impose that we have to, and there's no impact. Okay, so in this case it doesn't matter. Okay, let's change this value. I'm going to type 10. Okay, now I solve with these precedences, okay, and with a new time for the task, and I solve and I get a cycle time of 24. Now I'm going to remove the precedences. I'm just clicking del, and I solve again, and I have a lower cycle time. That means that even when the task is 10, whether you have precedences or not has an impact, because it does has an impact on or it imposes constraints on how you do this assignment. Okay, so I'm going to remove that task. Okay, and okay, we only have 12 tasks here, and so on. So this is all you can do. And well, finally, sorry, you can add the capacity of a station. Okay, in this case I'm going to reset everything and solve again. This is our initial situation. So what you can do now is to type 2 here, and that means that wherever is the time you have here actually will be divided by 2, because you'll have 2 positions to like having 2 stations, one that are working in parallel. So the time in between amplifiers should be reduced or divided by 2. So if we solve now, okay, this is what we have. Notice that the task you perform in station 2 take 15 minutes, the same for station 3, and station 4 16 minutes. But we have a 30 here, which shouldn't mislead you, because it doesn't mean that this station produces one amplifier every 30 minutes, but every 30 divided by 2. Remember, sorry, that you have to divide this value you obtain here by 2, because you have double capacity for this station. So you have been able to produce more by means of increasing the capacity of a single station. And again, what you have to do is to analyze if that is worth doing or not. Okay, and that's everything you need to know about how the solution is built and how you can use it. And I'll explain in the last video how to access it, because that might change over time, and in that case I will just change that video as the access changes for you to have the last information to be able to use this application.